In this tutorial, I will show you how to create a stat plot and determine the equation of the data. Once that's complete, we can then determine the instantaneous rate of change at a given point. First of all, I would like to reset the calculator in case there's already data entered in here. So go second function, the plus for memory, number 7 for reset, all RAM, so you can just hit enter number 1, and then number 2, or just hit arrow down to 2. Okay, so now that the RAM's cleared, we want to enter our data, so just press stat, and it's already on edit, so just hit enter, and we'll press 0, enter, 1, enter, 2, enter, and 3, enter. Then arrow over to L2 just with the arrow key, and go 1, enter. Let's say we enter 26 by accident. We can actually arrow back up to correct that and just press 16 again and hit enter, 21 and 16. Now if you hit graph, we'll see that we don't actually see anything. This is for two reasons. The first reason is the window is not set up with our data points, as well as we have to turn stat plot on. So first let's set up the window. So the minimum x value or a time would be 0 up to, we'll go up to 6 because we know it's going to still come down a little bit more. Y scalar or x scalar is still 1. Y min will go from 0 up to 25 just to be safe. Y scalar will count by 5s on our y-axis. Okay, so now when you hit graph, still don't see the graph, but these are counting by 1s, the y is counting by 5s. So next thing we'll go second function, the y equals, which is turns on the stat plot just above the y equals, and just hit enter twice. That actually turns it on. If you only hit it once, it'll stay on off, but it just brings it up. So now if we hit graph, we have our 4 data points. Now to find the equation, hit stat again, but this time we have to arrow over to calculate, and we're going to scroll down to quadratic regression because that looks like a quadratic or a parabola for a ball going through the air. Hit enter. Now we could hit enter rate again. That will give us our equation. Now I chose really nice points that gave us a nice relation. What we would have to do now is enter that in the y1 equals. Usually though we'll have a bunch of decimals, so instead let's go back to stat, calculate, go down to quadratic regression, and this time I'm going to put in brackets, and we're going to go L1, so second 1, comma second 2 for L2, and comma, now we've got to say where the equation is going to go, so we're going to enter that in the y1 spot, so you hit vars, then over to y vars, and just hit enter again if you want it in the y1 spot. Close your bracket and finally hit enter. So it looks the same as before, but now if you go y equals, it's actually in here. So if we hit graph, we don't only get our points, but we also get the curve. Now to find the instantaneous rate of change, our last piece, we can just go second calculate, our trace, and we see dy dx, which is kind of like the slope, right? It's the instantaneous rate of change at a specific point. So we'll hit number 6 and we'll calculate it at 4. And right away we get negative 20. So that would be negative 20 meters per second. The significance of the negative is that it's dropping. Okay. We could also do this by drawing a tangent. So you could go second, program for draw a tangent, and choose 4 again or whatever value you'd like. Okay. So that's for finding instantaneous rate of change.